Welcome back to computer science class. In the last video we discussed array and operations to be performed on array. The operations are traversal, insertion, deletion, searching, sorting and merging. These are the operations to be performed on array. Then array is one of the linear data structure. It is a linear data structure and it belongs to non-primitive data structure. Because array is a collection of homogeneous elements, hence it belongs to non-primitive data structure. And also we discussed traversal in array. In the last video we discussed traversal in array. Here traversal means we have to access all the elements of an array at least once. We have to reach all the elements of an array at least once. That is called traversal in array. In this video we discuss searching. The operation searching. Searching in array. We know that array is a homogeneous collection of elements. All elements are arranged sequentially. All elements share the same name and same data type. Here searching means find the location. Find the location of given element. Find the location of given element. That is called searching. To search a element in an array, we have two methods. We have several methods, but in your second PUC we discuss only two methods. The first one is linear search. Second one is binary search. In a search we have several methods, but here we only discuss two methods. The first one is linear search and second one is binary search. The difference between linear search and binary search is, in a linear search we have to access all the elements one by one, compare with the searching element. Starting from 0 to n minus 1 we have to access all the elements. Each elements are compared with the searching element. If it is found, we have to return a position. That is in linear search. But in a binary search there is a basic condition, that is the elements must be sorted. That is the basic condition to apply binary search technique over arrays. Element must be sorted. Then name itself says it is a binary search. Binary means we have to find the middle element, exactly middle element of a given data structure, that is given array. Then that middle element is compared with our searching element. If it is found, we say the element is found and returns the location. Otherwise verify if the given element, the searching element, is greater than the middle element or less than the middle element. If it is greater than or less than, based on that we have to modify our beginning and end, again apply the same binary search repeatedly until the given element is found. If it is found, we return the location, otherwise we return element is not found. So that is the binary search. But out of these two, linear search is a most effective searching. It is a most effective searching because linear search do not need any sorting mechanism. We have to access all the elements one by one. Element is found, return the memory location, return the position, otherwise we say the element is not found. Hence linear search is a most efficient, effective searching. But linear search take more time to return a location. Linear search takes more time to return a location. But binary search takes half of the time. It takes half of the time to return the location. If the elements are more in an array, then we use binary search. If the elements are less, then we use linear search. Let's discuss the first one, linear search method. In a linear search or also called sequential search, we have to access all the element. Here we access all the elements from array one by one. We have to access all the elements from the array one by one and compare all these elements to the searching element. All these elements to the searching elements. That is the technique in linear search. For example, let A is an array, have n number of elements. Then the elements are 5, 4, 10, 15, 12, 14. So these are the values present in an array. Then index values are 0, 1, 2, 3, 4, 5. These are the index values. For example, our searching element is 15. We have to find the location of the element 15. Then what is the linear search? We have to access all the elements of an array one by one. First we have to access first element, then it is compared with the searching element. If it is found, return the location. Otherwise, we have to access next element, compare with the searching element. How to access? Say first one is A of 0 is compared with the searching element. If A of 0 is compared with the searching element. If it is found, return the location. Otherwise, compare next element A of 1 which is equal to element. If it is found, return the location. Otherwise, access next element A of 2 which is equal to searching element. If it is found, return the location. Otherwise, access next element A of 3 which is equal to 15. Okay, searching element. If it is equal, then return the location. Here A of 3 have a 15, that is equal to searching element, then it returns the location. Location is the 3. So here name is same, only differ in the index values. For that we use the for loop. For I equals 0, I less than n, I plus plus. It is a for loop to access the array index values. Inside that we have to use if A of I value is equal to searching element. I value varies from 0, 1, 2. So every index values we have to access one element from the array. That element is compared with the searching element. If it is found, we have to return the I value. That is the location of a searching element. The searching operation returns the location of the element. So this is the linear technique. If it is found, then we have to return the position, that is the I value. At the same time, we have to stop the for loop using break. So finally we display the position. If it is position found, then element is found. If the position is not found, then element is not present in the array. So that is the technique in linear search. Let's write an algorithm to find the position of the element using linear search. That is algorithm to find location of element, here given element, using linear search. Algorithm to find location of given element using linear search. For that, let A is a array A is a array have n elements. A is a array have n elements. ELE is a element. ELE is a element to be searched. Element to be searched. Element to be searched means we have to return the location of that element. Element to be searched. LOC. Okay. LOC is a location of the element. Location of the element. Then following is the algorithm. Then following is a algorithm. Before writing the algorithm, you have to mention what is the name of the array, how many elements are present, which is the element to be searched, which is the location. So those are written in a statement. Let's start the algorithm. Step 1, start. Step 2, initialize location equals -1. Why it is -1? Initially the element is not found in an array. Index values start from 0 to n-1. Hence initialize location equals -1 means the element is not present in the array. In the step 2, okay, in the step 3, we have to access a element, that is for I equals 0 to n-1. I equals 0 to n-1. After that, if a of I value, here n is capital, n-1, so I value is equal to searching element ELE. A of I which is equal to searching element. So if it is true, if the element is found, so assign the location, that is location equals I value. And if, okay, at the same time if the location is found, then insert a break, then and if and for, then in the step 4, compare if location is greater than or equal to 0. Then compare if location is greater than or equal to 0, then output element is present, else output element is not present. Element is present or element is not present. Then end of if in the step 5, stop of the algorithm, end of algorithm, that is stop. Here instead of break also we write go to step 4. Either we insert break or go to step number 4. In step number 4, here we compare location is greater than or equal to 0, then output element is present. At the same time you have to print the position, else element is not present, though it is an algorithm. Starting of the algorithm, then we assume that element is not present, that is location is not found, element is not present, by assigning the -1. Why it is -1? Array index value is always positive number. First we thought that the element is not present in the array. So based on that we have to access all the elements from 0 to n-1. If it starts 0, then it is n-1. If you start 1, then it is n. Then compare if a of I value I value varies from 0 to n minus 1 is equal to searching element. A of I represents the element, I represents the index, array element is compared with the searching element. If it is found, note down the index value, go to the step number 4. Otherwise, access the next element, compare with the searching element. After closing of the for loop, compare if the location value is modified or not, position is modified or not. If the position is modified, if it is greater than or equal to 0, element is found. If it is negative value, location remains same, minus 1, negative value, then we say element is not present. So it is also one of the important algorithm in a point of examination. So in a linear searching, we have to access all the elements one by one, compare with the searching element. If it is found, note down the location, then take a decision. Otherwise, access the next element, compare with the searching element. That is the procedure in linear search. Let's write a C++ program. Okay, then program to find a location of given element using linear search. Given element using linear search. First write the include statements. Here we write an example program without classes and object. It is only an example program, not a lab program. All lab programs are written using classes and object, but it is an example program. So integer of array, first declare array with 20 elements. If it is an array, index and n are compulsory. Then also read the searching element, then position p. CLR, SCR, cout, enter how many elements. Enter how many elements. Cin extraction n. After that, read the array elements. Enter array elements. Enter array elements. So array elements, how to read? For I equals 0, I less than n, I plus plus. It needs a for loop. Inside that, cin extraction a of I value to read a array elements. After reading the array elements, I have to read searching element. Cout, enter a searching element. Enter a searching element. So how to read? Using cin extraction element. You have to read searching element. After that, initialize, then follow the algorithm. Say there we will initialize location equals -1. Instead of location, here we declare variable p. Initialize p equals -1. What is the meaning of p equals -1? The searching element is not present in a given array. That is the meaning of p equals -1. Then apply the logic. What is logic? Again access all the elements. For I equals 0, I less than n, I plus plus. It needs a for loop to access all the array elements. Inside that, if a of I value, array element, is equal to searching element, If it is equal, note down the position, that is position equals I value. At the same time, insert unconditional control statement, that is break. Close the for loop. Close the if and close the for loop. After that, take a decision. If position is greater than or equal to 0, output searching element is found. Searching element is found at display the position. Searching element is found at given position, so P. Else, if it is false, see out, searching element is not found. Searching element is not found. Close the double quotation, terminate the statement. Then finally, get character, close the main program. It is a program for linear search. So first we declare a variables needed are array, index value, number of elements, searching element and position to return, that is P. Read the number of elements, how many numbers, then read the array elements, also read the searching element. After that, apply the algorithm. Initialize P equals -1, that is given searching element is not present in the array, P equals -1. After that, read the array elements one by one. Then compare the array elements with searching element. If it is true, note down the position. I value is the position of the array that is assigned to the position P. Then stop the iteration. Break is used to stop the iteration. If the element is found, not necessary to access the next element. Hence, insert a break. After termination of for loop, compare if position is greater than or equal to 0. If maybe 0 position, 0 means first position, element is also found in the first position. Hence here P is greater than or equal to 0, then the element is found. So then say element is found and return the position. Otherwise element is not found. Otherwise means P equals -1. If it is P equals -1, element is not present. Display that searching element is not present. Where? In given array elements. So that is the program. Let's discuss the next method, that is binary search. To find the location of an element using binary search, there is a basic condition, that is array elements must be sorted. If array elements are sorted, then we apply binary search method. If it is not sorted, then we can't apply the binary search method. The elements are sorted either ascending order or descending order. Here we discuss the elements are in ascending order. We write algorithm and program if the elements are in ascending order. Let's see the method to search a element using binary search. Let A is an array, have n number of elements. Here 10, 20, 30, 40, one more 50. These are the values present in an array. Index values are 0, 1, 2, 3, 4. Let this is the beginning of the array, this is the end of the array, that is lower bound then upper bound. Already we discussed in the last video lower bound and upper bound. Lower bound is always 0, upper bound is always n minus 1. How to find the binary search technique in an array? It is a binary based on beginning and end value. We have to find the middle element. How to find? That is beginning plus end divided by 2. It returns the middle element. In this example, beginning is 0 plus end is 4 divided by 2, it returns 2. So the position 2 is a middle element. After reading the array element, also we read the searching element. Assume that the searching element is 40. Using this element, we have to access a of 2 element, that is compare with the searching element. What we do? Based on beginning and end value, we find the middle element. Here 2 is the middle element. Using array of n2, we have to access a element. The middle element is compared with the searching element. If it is searching element is found, we say element is found at the position. Otherwise, if it is not found, there is a two alternatives. First one is element is belongs to the first half or element is belongs to the second half. First we compare with the middle element. Here searching element is 40, the middle element is 30, element is not found. Then we compare if a of middle element is greater than or less than the searching element. We compare if element is less than a of mid, element is less than, element is, so here searching element is 40 is less than the middle element. If it is found, we have to modify the end, which is equal to middle element minus 1. When if the searching element is less than the middle element, else we have to modify the beginning by adding m plus 1. See here searching element is 40, middle element is 30, 40 less than 30, condition false. So we have to modify the beginning. How to modify? Middle element plus 1. So middle element plus 1, this is the beginning. Then repeat the same step. Find the beginning plus 2. So here beginning is 3 plus 4 divided by 2. So that is 3 plus 4. It is a integer division. So 7 by 2 integer division returns 3. So we have to access the a of n 3 element, which is compared with the searching element. Here a of 3 element is 40. So 40 is equal to 40. Searching element is also 40. Then return the position is 3. That is the process. So in a binary search, first we have to find the middle element. So 0, 1, 2, 3 are the middle element. Using middle element, we have to access the middle value. That middle value is assigned with compare with the searching element. If it is found, return the location. Otherwise, compare this. The searching element is less than the middle element. Searching element is less than the middle element. If searching element is less than the middle element, returns true. We have to modify the end because the element is belongs to the first half. We have to modify the end. If element is greater than middle element, then we have to modify the beginning. In this example, the element is found at the second half. This is the first half, second half. So beginning is modified to m plus 1, end is modified as m minus 1. So using this technique, again we have to repeat the steps until the element is found, or until beginning is less than or equal to end. Until beginning is less than or equal to end, we repeat the steps. So that is the process in binary search. Let's write an algorithm. To find the location of given element using binary search. For this, let A is an array have n elements. ELE is a element to be searched. Element to be searched. LB and UB are upper bound and lower bound. Upper bound and lower bounds. LB and UB are upper bound and lower bounds. B is a beginning of the array. B is a beginning. E is a and. E is a and M is a middle element. Middle of the array. B is a beginning, E is a and M is a middle of the array. Then following is the algorithm for binary search. Let's start the algorithm. Step 1, start. Step 2, first initialize set E equals lower bound, okay, beginning, that is B equals lower bound, E equals upper bound. First we have to set beginning equals lower bound, end equals upper bound. Then step 3, again here also initialize position equals -1. Initialize position equals -1. In the step 4, while beginning is less than or equal to and then. While beginning is less than or equal to and then you have to find the middle element. How to find? That is middle element equals integer of beginning plus and by 2. It is an integer division of beginning plus and by 2. Then compare if element is equal to a of n mid. We have to compare if element is equal to a of n mid. Note down the position which is equal to m. Then directly go to step number 5. Go to step number 5. Else if this condition is false, move on to the else part. If element is less than a of n middle value, then see here element is less than the a of middle value, then we have to modify element is less than a of middle value. We have to modify the end. How to modify? m-1 else beginning equals m+1. If it is element present in first half, element is less than the middle value, belongs to the first half, you have to modify the end. If this condition is false, means element is belongs to the second half, you have to modify the beginning. And if then and while. And if and while. So repeat this same step. In the step 5, you have to compare if position is greater than or equal to 0. If position is greater than or equal to 0, then output element is present, searching element is present, else output element is not present. Element is not present. And if in the step 6, stop. The step 6, stop. That is the algorithm to find the location of an element using binary search. See here, first we have to set beginning and end. Beginning is the lower bound, starting address, end is the upper bound, that is n minus value. We have to set 0 and n minus value. Then assume that the element is not present by assigning position equals -1. Repeat the steps until beginning is less than or equal to end. How many times? Beginning is less than or equal to end. We not know the number of iterations. Hence here we use while. While is a pre-tested looping statement. If the iterations are not known, then we use either while or do while. If it is a fixed, we know the number of iterations, then we use for. But here we not know the number of iterations, hence here we use while. Beginning is less than or equal to end. If this condition is true, every time you have to find the middle element. How to find? Beginning plus end by 2. It returns the middle element, middle index value. Using middle index value, we access the middle element. Then compare with the searching element. See the condition. If element is equal to a of m, then either we write if in a uppercase. If element is in a of m, then if this condition is true, note down the middle element, that is position equals m. What is the initial value? -1. It is in negative. If the element is found, note down the middle value. Go to the step number 5. Otherwise, this condition is false. Then we have to verify whether the element belongs to the first half or second half. If it is in first half, when it is in first half, element is less than a of m. The condition is element must be sorted. The array elements must be sorted. If it is searching element, EL stands for searching element, it is less than a of mid. So it is less than a of mid. See here, this is the array elements. Then this is the middle a of m value. Assume that this is the searching element. Then this condition returns true. Element is less than a of mid. Element is less than a of mid. So initially this is the beginning, this is the end. If this condition is true, we have to modify the end value. How to modify? Already we searched for this element. So e minus 1. Okay, m minus 1. M minus 1 is the end value. This is the end. We have to modify the end. If element is present in the second half, when it is present in the second half, this condition returns true. That is, element is less than m returns false. Then the element belongs to the second half. So element is greater than a of m. If the element is here, then we have to modify the beginning. How to modify? That is m plus 1. This is the beginning. See here, m plus 1, middle element plus 1. Already we searched the middle element. So apart from middle element, we have to modify the end or we have to modify the beginning. If it is belongs to the first half, we have to modify the end by assigning m minus 1 value. If the element is present in the second half, then we have to modify the beginning by assigning m plus 1 value. Repeat the same steps until beginning is less than or equal to end. After that, we conclude if position is greater than or equal to 0. If it is greater than or equal to 0, element is present. At the same time, we have to print the position. Otherwise, element is not present. So that is the algorithm to find the location of an given element using binary search. Let's write a program for the binary search without classes and object. Let's write a program. To find location of given element given element using binary search. Using binary search. First write the include statements. Then write the main of the program. Then declare a local variables. Here local variables are integer of array, then index value, number of elements, beginning and middle element, position p, then searching elements. See the number of variables required. First array, I stand for the index value, n number of elements present in the array, beginning of the array, end of the array, middle element m. So use the lowercase m. P stand for position of the given element. ELE is a element to be searched. CLR to clear a screen. See out. Enter how many elements. Enter how many elements. It is a output statement. Then cin extraction n. Enter how many elements. Cin extraction n. Then read the array elements. See out. Enter array elements. Enter array elements. How to read? Using for loop. I equals 0, I less than n, I plus plus. Cin extraction array of index value. Array of index value. After reading the array elements, read the searching element. See out. Enter a searching element. Enter a searching element. The searching element is cin extraction variable ELE. It stores the searching element. After that, initialize p equals -1. P equals -1. Then beginning is always 0. End is the n minus 1. Initialize the variables. After initialization, while beginning is less than or equal to end, while beginning is less than or equal to end, find the middle element, that is beginning plus end divided by 2. It is an integer division. See here, it is a integer division because index values are always positive integer numbers. Here these are the index values. After that, compare if element is equal to a of middle value. Element is equal to a of middle value. If it is found, p equals m, break. Else if element is less than a of n middle value, if it is true, assign the middle element to the position, break, exit from the while. If this condition is false, then we have to verify whether the element is belongs to the first half or second half. Here element is less than a of mid means element is present in the first half. So we have to modify the end. How? By -1. Middle element -1. Else modify the beginning, that is m plus 1. Close the if. So here there is a if else, close the if. Then close the while. After that, conclude that if position is greater than or equal to 0, after closing the while, conclude that if position is greater than or equal to 0, if it is true, see out element is present at the position we have to print the position variable p, else output element is not present. Then get ch, close the program. See the logic. First we read the number of elements, then read the array elements, also read the searching element. After reading the array elements and searching element, initialize. First we have to initialize position equals -1. The meaning of the position equals -1 is searching element is not present in a given array. At the same time, initialize beginning from the lower bound, ending from the upper bound. B equals 0 equals n minus 1. That is the initialization. Then repeat the steps until beginning is less than or equal to end. B is less than or equal to end. Repeat the steps. Calculate the middle point, beginning plus end by 2. That is the binary search. For calculate the middle point, using middle point, access the middle element. Then at the same time, that is compared with the searching element. If it is found, note on the middle element, that is the position, exit from the iteration. If it is false, then verify if the searching element is belongs to the first half or second half. If it is first half, modify the end by assigning m minus 1. If it is in the second half, modify the beginning by assigning m plus 1, middle element plus 1. Repeat the steps. This is the main logic. Repeat the steps. When b less than or equal to e, beginning is less than or equal to end, returns false. Then take a decision. Conclude that position is greater than or equal to 0. What is the initial value of position? -1. If the element is found, the position is modified. So if it is greater than or equal to 0, element is found at the position, print the position. Otherwise, output element is not present in an given array. So that is the program to search a element using binary search. So in this video we discuss searching method. What is searching? To find the location of a given element in an array. Find the location of a given element in an array, that is called searching. There is a several methods to search a element, but in your second PU we discuss only two methods. First one is linear search, second one is binary search. In a linear search, we access all the elements, then each elements are compared with the searching element. If it is found, we return the position. If the element is not found, then we say element is not present in the array. That is the linear search. We have to access all the elements from 0 to n minus 1 index values. So linear search is a most efficient and effective programming, but it takes more time to return a value. Then next one is binary search. In a binary search, we have to find the middle element. Then that middle element is compared with the searching element. If it is found, return the position. Otherwise, we have to verify whether the searching element is belongs to the first half or second half. If it is in first half, modify the end. If it is in second half, modify the beginning. Repeat the steps. In every time, we have to extract a middle element that is compared with the searching element. So that is the technique in binary search. Binary search take half of the time to return a value. To return a value, it takes half of the time. So binary search is a most effective method. It takes shorter time to return a value, but the condition is to apply binary search, array elements must be sorted. Array elements must be sorted either ascending order or descending order. Here we discuss if the elements are in ascending order, then we apply these algorithm and programs. In the next video, we discuss insertion, how to insert an element to the array. Either it is in the given position, or it is in the beginning, or it is in the end. That is discussed in the next video. Thank you.